Alright, to explain how to insert into a linked list, I'm actually going to take a little bit of a different approach than usual. I'm actually going to try and make a Khan Academy style on a video on how we're going to do this. Because I think the great way is because linked lists are data structures, it's great to visualize how like the references to objects change as we insert something into a linked list. And a lot of times when we're working with computer science, we actually do a lot of diagramming out of how we're going to solve a problem. So I think this is a great way to do that is to use something similar to Khan Academy, or whiteboard basically. So, well, our goal is we want to basically insert into a linked list. So insert into link list. Okay, so what does that mean? Well, turns out there are really two cases when we look at this. So there are two cases, okay? And case one is going to be case one. We insert at index 0. Insert at index 0. So let's look at an example of this. So let's say let's do the favorite linked list. So we have a link that points to. So think of the environment diagram kind of method here. So we're going to have a link that looks like this. So this is going to be 1, and that's going to point to a linked list that has the element 2, and this is going to be pointing to a linked list that has an element 3, and that's of course going to be pointing to an empty linked list. And I'm going to symbolize the empty linked list by just drawing a slash through it. Alright, so let's say we want to insert, the element 4. So the way this function call is going to work is we want to insert. So I'm going to have 3 main arguments. The first one is going to be the link itself. So let me actually denote that with red. So we're going to have insert on the link. And then we're going to have our actual numbers that we're going to pass in. So let's say I want to insert 4 into the first position. So 4 into the first position, and the first position in the linked list is going to be the 0th index. So basically this is going to be, so let me denote this, this is going to be our linked list, this is going to be the item right here, so this is going to be our item, and this is going to be our index. So this is how this all works. So how do we actually go about inserting into a linked list? Well, to show you that, let me actually just take this link right here, and copy it over down here. So, oops, got some extra stuff, but it doesn't matter. But anyway, so what we're going to do is we have to make, well, first, in order to insert element 4, we have to first make a linked list of that. Like, there's no way we can insert, just put in a number into a linked list. We have to make a linked list element because linked lists always point to other linked lists. So that's a key idea here. So let's say I do that. So I'm going to basically make a link that's, oops, let me go to, okay, so I'm going to make a link that's made up of 4. And just for now, I don't really care what the rest of this is, but that's my linked list. So what I basically need to do somehow is I need to get this to be inserted in the 0th position. But hey, what I can do is I have to really just take this pointer and move it here. Okay, so I can do that. So I can basically erase this pointer, move this pointer to here. So let's do that. So take this and point it here. And then this pointer right here, so what's the rest of this linked list? It's my original link. So the key idea is to notice that inserting into a linked list is just a matter of replacing my first element with whatever element I want to insert and the rest of it with the original link. So what that looks like in terms of function calls, it's actually not too bad. So let's say, so inserting linked list at the end of the day is just link basically my element, which is going to be, I'm just going to call it 4 right now here. So in this example, it's just a matter of calling link on 4 and then passing in the rest. Remember, the rest of that is going to be our original link. So, and yeah, that's our first case of inserting at the index of 0. So notice how easy that is in a linked list. We don't have to do any iteration at all. We just basically return this. It's great. So this is why one of the usefulness, this is why linked lists are somewhat useful, because they're very good at inserting things into them very fast. So in this case of where we index as 0, pretty easy. Alright, so now let's go into the second case of inserting into a linked list. And the second case is basically we're going to insert into the middle of the linked list. One case we're not going to look at just for simplicity purposes is we're not going to look at the case where we have to insert at the end of the linked list. The reason is that, remember, we're defining two versions of the function where we insert into either the start of the, two versions of the function where we either return a new linked list or we insert by mutating the original linked list. So in the case where we mutate the linked list, it can get pretty complicated when we have to worry about the last index. So just take my word for it, it gets complicated. I don't want to make this too complicated, so that's why I'm doing that. So let's look at this case 2. So for this case 2, let's analyze the function call insert on this link the element 4 at the index 2, let's say. So basically what that means is we're going to be inserting right here. Okay, so that's our basic idea. So when we're inserting into a linked list, it turns out that inserting into the middle is kind of, in a weird way, a special case of inserting at the front. Because if we just isolate ourselves, forget for a second, I want you to forget that this linked list, right? So for a second, all I want you to think about is that this is the only linked list that matters. So what if this is the only linked list we have? Turns out that inserting in the middle is just a matter of inserting at the beginning. Same idea. So what we would do is we would take link, we would just return link of 4, and then this thing. And then we're done. So if this, again, this is if we only had this link to worry about. But the problem is we have this entire linked list. So this is a good idea, but we need to define it a little better. So how do we go about defining it a little better? Well, what we can really do is notice that once, so the key pattern to notice is that, hey, once I get, so first I have my linked list. If I go one step further, I get my next linked list, which is this right here, that element 2. Now, notice that if I only had this linked list now, basically this linked list right here, so forget the 1 for a second. If I only had that, it's a matter of inserting into the first index of this linked list. And then once I move one more into it, so I'm going to go one level deeper. If I go one level deeper, I get to this linked list, and that's just a matter of inserting into the 0th index. So here we see that we have a recursive solution at work. So the key idea is to understand that, hey, inserting a linked list, I need to get my linked list defined, and then at the end, it's just a matter of, so here's the big idea. We're going to basically we're going to return a new linked list, basically. So I'm going to do it not in the mutating example, but the mutating example is very similar, but what we're going to do is we're going to return link, and then now we have to understand that if we go on the link.rest now, sorry, we had to first put link.first, right? Because the first argument of the link constructor is link.first, and then now in here, what we can do is, so now we're going to go on insert on the rest of the linked list. So how do we insert on the rest of the linked list? Well, we can insert on link.rest. So this is where we go into the rest of this linked list. So this is our operation right there, and we're going to insert the element 4, and then now notice that once we get to this linked list right here, it's only a matter of inserting into the first index. So we had our index as 2, so we just take whatever our index was, whatever it is, and we're going to go -1. So this is the recursive definition of this. So just so I'm a little more clear, so here's our definition, so don't get confused. It's basically a link. So inserting into a linked list in this case is just a matter of creating the link dot first, because remember, we still need to keep track of whatever elements we pass through, and then now insert. So basically this thing right here, insert on link.rest for an index. So that's how this works. So anyway, I hope you found this diagramming useful. I think sometimes when you're working with linked lists, it makes a lot more sense if we go through and diagram the process and how the recursion works. So the reason the recursion works so well is because whenever we look at the rest of a linked list, it just happens to be a linked list, so we can do the same ideas with it. Okay, so anyway, now let's go into actually implementing this function.